Okay, first thing we do, of course, is read the question. So we're talking about a normal distribution here. So we're going to have a bell curve. Let's write down what it is we're talking about. What are we even modeling? My pad doesn't seem to be working. All right, so we are measuring the mean weight in grams of this fruit. By the way, I will give you guys an extra credit point. First person that sends me an email and tells me scientifically what's wrong with this question. There's something scientifically wrong. You have to think back to maybe your physics or your biology class about what's wrong with this question. I'm just going to go with it. I'm going to pretend it's okay, but there is something scientifically wrong. Think units. First person that sends me an email gets the point. Okay, so this says that the mean weight of this fruit is normally distributed. So let's write out, let mu be the mean weight. So mu is our parameter, our population parameter for population mean. And we're told that mu is 364 grams. So that means we've got some kind of bell curve here. And right in the middle, the average weight is 364 grams. That's also the median because normal distributions are perfectly symmetric. So half of the fruits weigh below that and half are above. Okay, I want to know, we pick one at random, what's the probability it's between these two numbers? So I'm going to put this on my picture. This is step one, draw the picture. X is 301. And up here somewhere above the mean, X is 384 grams. Okay, I find each z-score. So draw the picture and shade what it is you're trying to find. That's the area I'm trying to find. I find my z-scores. Remember, z-score for, let's say, the 301. Our formula is z equals x minus mu over sigma. We were also told our standard deviation, sigma, was 25 grams. You can memorize this formula here if you want, but we're going to have like 7 different formulas for z-score this semester. I don't recommend just memorizing a formula. Understand what a z-score is. The z-score is how many standard deviations you are above or below the mean. So when I say z-score, I want you to think the one I want minus the one in the middle of that picture I just drew, divided by that standard deviation I probably just found. So 301, that's the number I'm interested in now. That's the one I want. Minus, what number was in the middle? The mean, 364, divided by my standard deviation. Okay, I want to point this out real quick here. A lot of mistakes happen here. People will type this. They'll type 301 minus 364 divided by 25. And they'll hit enter. And they'll get a z-score like that. If you ever get a z-score of 286, you've done goofed somewhere. The probability of that happening in the real world is so small that it would never happen in the lifetime of the universe. Like that's an impossible event. Your z-score is never going to be 300. There's one problem we do later this semester where we get a z-score of like 15. And the whole point of that problem is this thing we're trying to check on here will never happen. It's impossible. Z-scores, like a z-score of 4 is a big z-score. You're never going to get 286. I typed that wrong. That's a mistake. I'm supposed to take that top, subtract first, then divide. So I could do that with parentheses. I could do 301 minus 364, parentheses divided by 25. See, that's a reasonable answer, -2. Or I'm lazy. What I do when I'm typing it is I just type the top, hit enter, then divide by 25. Either way, this is the correct answer. That z-score is -2.52. That means that that fruit right there, that fruit that weighs 300 grams is 2.52 standard deviations below average. How do we know it's below? Well, for one thing, like there's the average, it's below, it's lower. The average is 364, it's only 301. Another way we know it's below is that's what a negative z-score is. Negatives are below, positives are above. Okay, what about the other guy? That was just one z-score. Now the other one. So for 384, his z-score, that's a z, is the one I'm interested in, minus the one in the middle of the picture I just drew, divided by my standard deviation. So again, we type that in the calculator, and I'm lazy. I'm just going to type the top, hit enter, and then divide by the bottom, 0.8. So that fruit, the one that weighs 384 grams, is 0.8 standard deviations above the mean. That's kind of a heavy fruit. Not really heavy. One standard deviation, it's not that far away. Remember, the standard deviation is like a ruler. It's a measure of how far you are from the mean. And one standard deviation above the mean is not that far. So that fruit's a little bit heavy. That one's pretty light. 2.5 standard deviations below the mean is pretty light. Okay, z-scores are only your final answer if the question says find the z-score. So like, look, if we look at the homework here, this question says find the z-score. You get the z-score, you type it in, you're done. That's the answer, because that's all they asked for. Usually that's not what we're asking though. Unless the question says find the z-score, z-score is not your final answer. Never add or subtract z-scores. I can't add these together. Never multiply z-scores. What we do now is normal CDF. That's a button on our calculator. The smallest z-score up to the largest. Sometimes our smallest will be -infinity. If I had shaded all the way down here, way down there, is z equals -infinity. If I'd shaded way all the way up here, this is z equals +infinity. That we can't type that in the calculator, so we would type -99 here or +99 here. But that's not what we have. We didn't shade all the way out. we stop shading at these two spots here. So smallest thing we shaded up to the largest. So we get our fancy calculator out. We're going to go right here into this button that says distributions, right above VARs. Make sure you keep a note, keep a page of all the different buttons on the calculator and how to get to them. So second distribution to get there. We're never going to use number 1, ever. We want number 2, normal CDF. The smallest and the biggest z-scores that I shaded to. Okay, here's another place mistakes happen. I'm trying to type that number right there, -252. People will type this. And then for upper, 0.8. Okay, so I'm going to point out 5 different things here all at once. To type that one, I hit this button right there. And watch what happens. I get an error. That's because this is the minus button and that's the negative button. I don't want minus, I want negative 2.52. The negative button, not the minus button. Second thing I want to point out here, common mistakes. This one has to be smaller than that one. It has to go small to big. If you've got these backwards, you're going to get crazy answers. And the other thing I want to point out is never change these two. I know there are shortcuts you can use. If you go to the tutoring center on East Campus, they might try to show you a shortcut you can use here. If you completely know what you're doing, that's fine. I understand there are shortcuts. If you know what you're doing, feel free to use them. My experience is once people start using the shortcut, they don't really understand what they're doing and they mess everything up for the rest of the semester. Like if you mess this up and you don't know what you're doing, you will get every problem wrong for the rest of the semester, every single problem. So my suggestion is don't mess with these two numbers right here. Leave those alone. That should say 0 and 1. Lowest, biggest z-scores. These have to be z-scores. Leave those 0 and 1 and hit paste. Now, if your calculator doesn't look like that, if it didn't look like my screen, if all you see on your screen is normal CDF and the little blinker, then you would just type, like obviously this won't work on mine, but you would have normal CDF blinking. You would then type -2.52, comma, 0.8. You would close your parenthesis because you would have this much of the screen. Like that right there would already be on the screen. And then you would hit enter. Obviously, if I hit enter here, it's not going to work. Okay, so that's my answer. 0.782. You probably want to go 3 places here. You will never get an answer bigger than 1. You can't have more than 100% probability. 0.782 is my answer. That means the area that I shaded there is 78% of the total population, or 78.2% of fruits are between 301 and 384 grams. Or the probability that I pick a single fruit and it weighs between those two is 78.2, whatever. So which one was that? It was number 24. There's the answer.